So if you don't mind, I'll just kind of present from here to start while that works on that. Hello, my name's Ian, and I'm presenting two different projects at the moment, but they're both rather brief. So the first of the two is CS tools. I'm not sure if you can see these slides, but they're rather small. But so the idea of this project was to teach common programming tools through code examples and basically reference sheets. So why would we bother doing this? Like, why would I even make this an ARCOS project? So I've talked to a lot of people, and learning computer science is kind of difficult on its own. And then you jump into something like data structures, computer organization, algorithms, and nobody really tells you how to use something like GCC, GDB, how to properly use Microsoft Visual Studio or its compilers or debugging system. So the idea is to give them code examples and brief reference sheets, so then they can run through that and figure out how to do it on their own alongside a course. So then you're not as lost. You know at least the names of tools that are out there, and you can find stuff for yourself. I was actually recently talking to a friend of mine who's a senior, and he never learned how to use GDB. So we're doing this SD&D project in C++, and he's sitting there and he is making a print statement every single time he wants to see a variable name, and is recompiling our massive code base every single time he needs to make some debugging change. And we're like, why don't you just use the G flag and run it through GDB? And he said, what's that? And I died a little. So, in general, this is just to replace some of that extra hand-holding that I personally got from older students who knew what they were doing with these tools, and so that people know more where they're going in each of these classes. Life is hard. You see it, but so our solution to this is just, like I said, provide really concise, not really tutorials, but basically just lists of things with brief descriptions. So if you look, it gives you 5 bajillion functions and things that you can do with it. But really, the basics of what you need to know are how to step forward, how to step backwards, how to step into functions, things like that, at a breakpoint. So the idea would be give them reasonably lengthy code examples that are physically broken, that they need to step through, and it will give them pretty tidy example output of what they're looking for. So, for example, one of the ones that I've been working on is a simple segmentation fault. So I have a data structure that I've written very poorly, and it accesses memory that no longer exists because the pointer went out of scope, and it is not dynamically allocated. So it's just running through that. It finds a problem there, and then it being, GCC, if you compile that and run it, it will just barf everywhere. And then you've seen those screens, those lovely long screens of addresses. So
like core dump.
Like the first time I saw that as a freshman in data structures, I had like a few hours left, and I needed to get my assignment in, and I was just sitting there, and that happened, and I had no idea what was going on. Yeah, I think I did just end up submitting it anyways, but I was utterly lost, and I don't think you should be there. So like, also when you tell people about things like GitHub even, they're absolutely terrified of using these things. They're like, oh, it's command line, oh, you have to use Linux, no, I can't do that. That's far too terrifying for me. And I'm kind of like you're a computer science major, or you're CSE, EE, and you spend a lot of time working with these types of systems. You should try this out. So the planned topics that we originally organized, we being my group who vanished, is getting your system set up properly. So I didn't know about MinGW until earlier this semester, and like I had it magically, and I didn't know why G++ was a thing on my computer, and I just kind of let it be, and I knew that it came from installing Strawberry Perl. So when I wanted to use G++, I installed Strawberry Perl, and that was very silly. So just getting your stuff set up, just brief paragraph, why would you use each thing? Because at least amongst my friends, there is a lot of hate for Microsoft Visual Studio, but there's distinct reasons why you would use Visual Studio. So just list pros and cons, list Linux distributions, things you need for setting up on Windows, Mac, Linux. Shell usage. So I know if you take computer organization with Christopher Carruthers, he goes over Shell and how to use Linux for about a month. And if you know Shell, then you are bored out of your mind and you don't pay attention. And if you do not know Shell, then you are lost utterly because he just types quick commands and goes over it, and then people who don't know what they're doing cry. So just brief thing of how do you navigate, how do you get help, and how do you do some of your basic operations. So for example, another thing that makes me cry is when people use Shell a lot and they don't know grep. I don't know how you can use shells without knowing how to use grep. It is possibly the most useful tool ever. How to use a compiler. So, I mean, just typing g++-o to compile something isn't too difficult, but then when you get to linking other libraries, so you have like if you're compiling OpenGL, for example, the -lglu and -lgl like extra flags, or adding things like the wall flag, so then it makes all your warnings into errors, or even just including extra directories for your compiler to search through. So, you know, the -i flag where you're like, oh, well, I actually have header files separated out into a different directory for whatever insane purpose. Debugging, I talked about that a little bit. So we go over GDB, how to use that. Valgrind is something that I am still terrified of using because I don't know what it's doing. And Dr. Memory, also the same thing, I don't know what's going on. But, so that's something that Matt McMullen used to be helping me on this project. He unfortunately couldn't continue for the semester, but he is very good at that stuff. And he was teaching me how to do it, and we were like, somebody else needs to see this brief tutorial. LaTeX, I think, I die a lot inside. One of the things that made me die a lot was algorithms, where like I picked up LaTeX because, I don't know, I was bored in data structures after I learned GDB. And getting to algorithms when people were handwriting their assignments and you had those like 5 pages of proofs and it's scribbled, I looked at the TA and I could see him staring at that pile of handwritten things and he just looked incredibly sad. So LaTeX is something that, just briefly cover it, I know people are terrified of that as well. Build systems like CMake, those are a little hard to get into, but it really isn't that hard to just make a make file even. And source control. So I recently had somebody tell me that Git was too hard to use in Game Dev 1. But they were using Dropbox. You were joking about that before, but they legitimately use Dropbox for version control. And
people do try and use it, and it's horrible.
It's I wouldn't say funny, but so progress so far. I used to have a group of 3, and I kept trying to do this project, and we kind of petered out a little bit, which is why I picked up my old project for working this semester. So I'm currently the only person. If you want to join me and help me with this, then by all means, more people and more knowledge is great. Like, you know, help teach future people how to use stuff that you really like to use. So I've gotten, you know, the setup. I finished that. I got shell usage down, and I got partial written write-up of like the basics of what you need to know for LaTeX. I also do have some code examples for GDB, but I didn't list that because I don't think my code is very good. It's kind of a trivial example. I'm not very good with memory and things like seg faults. So I get seg faults, and I just sit there and cry. So if any of you are experienced with making seg faults, or controlled making of seg faults, I'm very good at making seg faults. But if you can make them in a controlled manner that, you know, a newbie wouldn't have too much trouble figuring out, then that would be awesome. So, like I said, I need help. I'm hoping that maybe I can get my group back next semester. But if anybody here wants to become the new group, that would be awesome. We need to write up sections, we need to fill out existing sections, and then our focus, which is why we actually put it in for Arcos, is that we wanted code examples. So we don't want it to be like You sit there and read your tutorial. We wanted it to be like, oh, cool, debug this code. Let's give this a try. And you just spend an hour and figure out how to use GDB by debugging this section of code. So we need much more code example. And we also need any ideas or suggestions for things that you use frequently. So this is like my question section for this part. Is there anything that any of you use really frequently that you find to be completely integral to your life as a programmer? Yes? No?
Stack Overflow, Google.
Stack Overflow, honorable mentions maybe. Yeah?
I want to go over some like editor shortcuts, like Vim shortcuts or shortcuts.
Yes. That was part of the setup that I wrote. I actually put that in with setup. I'm a Vim user, so I put in a bunch of basic things for Vim that I kind of skimmed over when I was reading Vim tutorials. So the basics of why you really should use HJKL movement, how to edit your vimRC, stuff like that. Registers. That was magic. What?
We have Screen.
Screen, yeah, that would be a good one. Okay, Screen and Tmux.
Especially how to disconnect from screens.
And using it for like...
for a while and I did not kill them.
You know, Josh,
The disconnects, those are killer.
Nifty's shell scripts to interface with different screens on a basis of running Minecraft servers, but I'm sure you can extrapolate to better
That would be excellent.
better things.
I think other things that would be good for screen is like using it as a serial, using it for serial stuff. When you're debugging stuff with that, or in general, just using it. Yeah, good suggestions. So, all right. Well, that is the first project. The second one, this is, if you were here over the summer, this was my project for the summer. It's called Big for the novelty of running the commands Big Bang and Big Crunch. The general idea was that it's a system configuration storage and management system. This is a fairly short project, so I'm just working on this by myself. It's mainly for all of you who you set up your Linux system, you have it the way you like it, and then you do something like you decide to switch window managers, and you decide that you want to edit your grub config manually, and something goes horribly wrong, and you can't recover your system at all. So you want your nice Linux setup back, but maybe you have something like Arch Linux, or maybe you're just lazy and you have Debian and you just don't want to bother setting that up again. So you don't want to have to figure out, my biggest problem is remembering what packages I had installed. So I'll just like run a command in the shell and I'll just be like, oh yeah, that's a package I needed, right? So my biggest problem on Arch is remembering to install sudo, or sudo. I think people will get mad if I pronounce that wrong. So yeah, once I get a not root account on Arch Linux, I am absolutely lost, and I'm just like, oh dear, what happened to sudo? So this just grabs a list from your whatever package manager you're using. Currently, it supports Debian-based stuff using Aptitude and or actually dpackage. It supports anything that uses dpackage and whatever uses Arch Linux's pacman thing. So it'll grab a listing, it'll make a manifest file, and you can write configurations to exclude or include packages. So if you really want to store that you installed all of Xorg and whatever else, then you can store that. Or you can just tell it, I want you to re-download Vim, Xmonad, Xmobar, and dmenu. And you can tell it to just store those. Or various regular expression things in the middle. It'll also grab your configuration files. So one that I forget all the time is input.rc, which lets me do lovely VI-like bash stuff. So I always forget that, and I always have to rewrite it or re-look it up on the internet to figure out how to do it again. But so it'll grab your configurations, put them in a little archive thing, and redeploy it when you run Big Bang. So the crunch will just grab all the stuff, make a little like tarball. I think currently it's a tarball, and then you just put that on like your external, and then you can unpack that later, and it will automatically put them back properly. So current state is it has its package listing, but instead of making a manifest file, it just kind of makes a shell script. So you have a shell script and a bunch of configuration files, which is interesting. It works on Debian properly, and I almost have it working properly with Arch Linux. And yes, dam. Yes, it's a water dam. But it is pretty darn buggy. And it needs some work. My shell scripting skills are rather poor. So for recent progress, I made stuff to support the manifest file, basically. So I have XML parsing that I wrote from scratch, which is also where my data structure debugging code came from, because trees, I guess, are not my strong point. Arch links to compatibility, and I was using flat C for whatever masochistic reason. And now it has objects and things like streams, which made life a whole lot easier, instead of using scanf and printfs everywhere. So planned work, compatibility with more package managers, so there's like the Yum packages or whatever that is, and RPMs, that sort of thing. Support for locally stored packages, so I really do not want to lose all of my packages from the Arch user repository. So I would like to just keep those locally so I don't have to re-download them later, although it's not too difficult. Better filtering and configuration options, so it sort of works with regular expressions right now. So if you tell it to exclude everything that it contains XOR in it, it will attempt to, but sometimes those make it through and I don't know why. I was going to try and actually implement hooks, so every time you ran your package manager, it would update your manifest for you. But I still don't know what I'm doing with hooking. Something that I thought might be useful is compositing archives together, so you have two of them and you're like, take the configs from this one and the package listing from this one and make a new archive. And eventually maybe I was thinking getting it to create meta packages, so instead of having like a script that unpacks it for you or just having the program unpack it for you, it generates a meta package which you can install, which will make it nice and tidy. So, hope that wasn't too fast. Any questions?
Why C++?
Because it's not C and it has objects in it.
Why not like Bash or Python?
I could, but I like pain and suffering.
Oh, okay.
Actually, it was mainly for data structure support. I'm not too experienced with Bash data structures stuff. I know there's like JSON or whatever it is. Well, I mean, storing stuff.
There you go.
So, lack of experience with Bash scripting really is the answer to the Bash part. And then why I didn't use Python, I have no idea.
It just seems like interfacing between C++ and like all of like file system, shell command stuff.
File system is actually really easy. You know how like in Python you just say like system and then command? You do the same exact thing in C++. And I think that might be what led me to do it in C, because that's like a C thing that carried over. So
one of the reasons that I can think of off the top of my head why you shouldn't use Python is because if you get a new system that doesn't have Python installed, that just defeats the purpose of your program. Like, what do you mean I don't have a package installed? I'm trying to install all my packages.
You can shoot that
And that's what you should use. That's
And I have another question.
yes.
So Bash has been the like very popular shell for a while, but like in the last month, ZSH has kind of just exploded. Like if you look at GitHub, oh my ZSH is the most everything. Like the most fork, the most start, the most commits. Like it's crazy. And I'm just wondering, like for things like that, like let's say you have like C shell or ZSH installed. Is it also going to grab like those configuration settings? Or is it, like you have to tell it to find those?
Right now, it searches or at set UTC / whatever for anything that ends in conf, and see if those are viable. And it also runs through your home directory looking for things that end in conf. I don't know why you have those there, and things that are like XRC. So something that ends in RC. And it sort of works. I haven't used Z shell before, and I've never used C shell in my life. So I don't know what the differences are, and I don't know how to support that. But that's like definitely something I was hoping to manage. And that would also be why I generate meta packages instead of a shell script, in case there is a distinct difference between something like C shell scripts and Bash. But yes, I would like to support that. I think people are about to leave, and unless anybody has anything else, thank you to Sean Sullivan.